Changing out several panels from 175 amps to 200 amps, fed from a single older service, may indeed raise code issues. The National Electrical Code, or NEC, requires that the service capacity be adequate to supply the connected load. Upgrading the subpanels to 200 amps increases the potential load in the service, which may exceed the capacity of the existing service. Older service equipment may not be rated for the increased load of 200 amp subpanels. This includes the main breaker, disconnect switch, and service conductors. The wire size between the service and the subpanels may need to be increased to meet the higher current demand of 200 amp subpanels. If the existing service is a 3-wire system with no neutral, adding 200 amp subpanels may require installing a neutral bonding jumper at the service entrance to establish a grounded neutral system. To address these potential issues, firstly assess the service capacity. Calculate the total connected load of all the upgraded subpanels and compare it to the existing service capacity. If the capacity is exceeded, consider upgrading the service to a higher amperage. Secondly, inspect the service equipment. Ensure that the existing service equipment is rated for 200 amps. If not, replace it with appropriately rated equipment. Thirdly, increase the wire size. Determine if the existing wire size is sufficient for 200 amp subpanels. If not, replace the wires with a larger size that meets the NEC requirements. Fourthly, establish neutral bonding. If a neutral bonding jumper is required, install it as per the NEC specifications. Here's a more detailed look at each of these points. Assessing service capacity involves a load calculation. This is a systematic process to determine the total electrical demand of a building or residence. The NEC provides guidelines for calculating these loads, ensuring the electrical system can safely handle the anticipated demand. The load calculation typically includes general lighting and receptacle loads, appliance loads, heating, ventilation, and air conditioning, or HVAC, loads, and any other significant electrical equipment. For general lighting and receptacle loads, the NEC specifies a minimum load per square foot, which varies depending on the type of occupancy. For example, a dwelling unit has a different requirement than a commercial building. Appliance loads are calculated based on the nameplate rating of the appliances. For continuous loads, which are loads expected to operate for 3 hours or more, the NEC requires that the branch circuit and feeder be rated for 125% of the continuous load. HVAC loads are calculated based on the nameplate rating of the equipment, including both the heating and cooling components. After calculating all the individual loads, they are summed to determine the total connected load. The NEC allows for demand factors to be applied to certain loads, which recognize that not all loads will operate simultaneously at their maximum rating. These demand factors can reduce the calculated load, but they must be applied carefully and in accordance with the NEC guidelines. Once the total connected load is calculated, it is compared to the existing service capacity. The service capacity is determined by the rating of the service entrance conductors, the main breaker, and the service equipment. If the calculated load exceeds the service capacity, the service must be upgraded to a higher amperage. Upgrading the service involves replacing the service entrance conductors, the main breaker, and the service equipment with components that are rated for the higher amperage. This work must be performed by a qualified electrician and must comply with all applicable codes and regulations. Inspecting service equipment involves checking the main breaker, disconnect switch, and service conductors. The main breaker is a critical component of the electrical system as it protects the entire system from overloads and short circuits. It should be properly sized to match the service capacity and should be in good working condition. The disconnect switch is used to de-energize the entire electrical system for maintenance or repairs. It should be easily accessible and should be clearly labeled. The service conductors are the wires that connect the utility company's transformer to the building service equipment. They should be properly sized to carry the anticipated load and should be in good condition. Look for any signs of damage or deterioration, such as cracks, corrosion, or loose connections. If any of these components are not rated for 200 amps, they must be replaced with appropriately rated equipment. When replacing service equipment, it is important to select components that are listed and labeled by a recognized testing laboratory such as Underwriters Laboratories or all. This ensures that the equipment has been tested and meets safety standards. Increasing wire size involves determining the appropriate wire gauge for the 200 amp subpanels. The NEC specifies the minimum wire size for various amperage ratings, taking into account the type of conductor, the insulation temperature rating, and the ambient temperature. The ampacity of a conductor is the maximum current, in amps, that a conductor can carry continuously under specified conditions of use without exceeding its temperature rating. The NEC provides ampacity tables that list the ampacity of various conductors based on their size, material, insulation type, and installation method. When determining the appropriate wire size, it is important to consider the voltage drop. Voltage drop is the decrease in voltage along a conductor due to the impedance of the conductor. Excessive voltage drop can cause equipment to malfunction and can reduce the efficiency of the electrical system. The NEC recommends limiting the voltage drop to 3% for branch circuits and 5% for feeders. To calculate the voltage drop, you need to know the length of the conductor, the current flowing through the conductor, and the impedance of the conductor. There are various online voltage drop calculators that can assist with this calculation. If the existing wire size is not sufficient for 200 amp subpanels, it must be replaced with a larger size that meets the NEC requirement. When replacing wires, it is important to use the correct type of conductor and insulation. The NEC specifies the types of conductors and insulation that are permitted for various applications. It is also important to properly terminate the wires using listed and labeled connectors. Establishing neutral bonding involves installing a neutral bonding jumper at the service entrance, if required. A neutral bonding jumper is a conductor that connects the neutral conductor to the grounding electrode system at the service entrance. This creates a low impedance path for fault current to flow back to the source, which helps to trip the overcurrent protective device such as a circuit breaker or a fuse, and clear the fault. The NEC requires that the neutral conductor be bonded to the grounding electrode system at the service entrance in most electrical systems. However, there are some exceptions, such as separately derived systems, where the neutral conductor is bonded at the source of the separately derived system. If a neutral bonding jumper is required, it must be installed in accordance with the NEC specifications. The size of the neutral bonding jumper is determined by the size of the service entrance conductors. The NEC provides tables that list the minimum size of the neutral bonding jumper for various service entrance conductor sizes. The neutral bonding jumper must be made of copper or other approved material and must be securely connected to the neutral conductor and the grounding electrode system. The grounding electrode system typically consists of a ground rod, a metal water pipe, or a concrete encased electrode. It is always advisable to consult with a qualified electrician to determine the specific code requirements and to ensure a safe and compliant installation. A qualified electrician has the knowledge, skills, and experience to properly assess the electrical system, perform the necessary calculations, and install the equipment in accordance with the NEC and local codes. They can also identify any potential hazards and take steps to mitigate them. Working with electricity can be dangerous, and it is important to take all necessary precautions to prevent electrical shock and other injuries. Always de-energize the circuit before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electricity, it is best to leave the work to a qualified electrician. Remember that electrical codes and regulations are constantly evolving, so it's crucial to stay informed about the latest requirement. Local jurisdictions may have additional requirements beyond the NEC, so it's essential to check with the local building department to ensure compliance. Proper planning and execution are key to a successful and safe electrical panel upgrade. By carefully assessing the existing service capacity, inspecting the service equipment, increasing the wire size as needed, and establishing proper neutral bonding, you can ensure that the upgraded panels will operate safely and reliably for years to come. Failing to address these issues can result in overloaded circuits, overheating wires, and potentially dangerous electrical hazards. The NEC is a comprehensive set of standards that provides detailed guidance on all aspects of electrical installations. It is updated every 3 years to reflect the latest technological advancements and safety practices. Familiarizing yourself with the NEC is essential for anyone involved in electrical work. In addition to the technical aspects of upgrading electrical panels, it is also important to consider the aesthetic aspects. Choose panels that are aesthetically pleasing and that blend in with the surrounding environment. Ensure that the panels are properly labeled and that the labels are easy to read. Keep the area around the panels clean and free of clutter. A well-designed and maintained electrical panel can enhance the overall appearance of a building or residence. Finally, remember that electrical work is not a do-it-yourself project for the inexperienced. It requires specialized knowledge, skills, and equipment. Always hire a qualified electrician to perform any electrical work. They will ensure that the work is done safely, correctly, and in compliance with all applicable codes and regulations. Investing in a professional electrical installation is an investment in your safety and the safety of your property. Remember to check your local and state laws for permitting that may be required for electrical work.